For almost 4 decades, Uranus had everyone fooled. It sat out at the edge of the solar system, a smooth, quiet, pale blue marble, and we believed the disguise completely. We thought it was boring and called it the planet nobody wanted to visit. The last real look came in January 1986, when Voyager 2 swept past and photographed almost nothing. A featureless ball, no storms, no drama. Then James Webb turned its eye on Uranus, catching wavelengths of light invisible to us, and the quiet planet vanished.
This means that the magnetic field around Uranus is dynamic and can fracture and interact with the solar wind in very interesting ways.
Uranus was never calm. It was hiding. And once you learn what was happening beneath that smooth blue face, those old pictures start to feel unsettling. The strange discovery of Uranus. To understand why Uranus is so unusual, you have to start with the night it was discovered. The year was 1781. In England, William Herschel was scanning the night sky with a telescope he had built himself. Herschel was not just some casual stargazer. He was a musician, a telescope maker, and a man who spent night after night searching the sky for objects that did not behave the way ordinary stars should. Then he found one. At first, he did not know what he was looking at. It did not seem like a normal star, but it also did not immediately announce itself as a planet. Every planet known before Uranus had been known since ancient times. Mercury, Venus, Mars, Jupiter, and Saturn could all be seen with the naked eye. Uranus was different. It had been there the whole time, but it was too dim, too slow, and too easy to mistake for a star. It took more observations before astronomers accepted that this was not a comet at all. Johann Elert Bode helped push the idea that Herschel had found a new planet, not just another wandering object. Herschel even tried to name it Georgium Sidus, after King George III. The name did not last. The planet eventually became Uranus, named for the Greek god of the sky. But the real shock was what kind of planet this thing turned out to be. Because even after humans found Uranus, we still did not understand how wrong it was. Most planets spin in a way that at least feels normal. Earth leans a little as it moves around the sun. That lean is why we have seasons. It is enough to change the weather, but not enough to make the whole planet look broken. Uranus is not like that. Uranus is tilted by 97.77 degrees. That means its equator is almost at a right angle to the path it takes around the sun. In simple terms, the planet is almost lying on its side. Earth spins like a top with a slight lean. Uranus rolls around the sun like a ball knocked over on the floor. That one detail changes everything. Scientists think this strange tilt may have come from a violent collision long ago. Something about the size of Earth may have slammed into Uranus in the early solar system, hitting it so hard that the planet never stood upright again. Billions of years later, it is still moving through space with that damage built into its body. And because Uranus is lying sideways, time itself feels wrong there. A day on Uranus lasts about 17 hours. That part sounds fast, but its year is a different story. Uranus takes about 84 Earth years to make one full trip around the sun. One Uranian year is longer than many human lives. Now add the tilt. Because the planet is turned almost sideways, one pole can face the sun for nearly a quarter of that long year, while the other side is trapped in darkness. That means one half of the planet can sit through a dark winter lasting about 21 years. Not 21 cold nights, 21 years. A child could be born during one of those long polar nights, grow up, and reach adulthood before the darkness finally started to break. And even when the sun does shine there, it is not the warm, bright sun we know on Earth. Uranus is about 1.8 billion miles from the sun. That is roughly 19 times farther away than Earth. From that distance, sunlight takes about 2 hours and 40 minutes just to reach it. By the time that light arrives, it is weak. Daytime on Uranus is not bright and comforting. It is dim, distant, and cold. And once a planet spends its life rolling sideways through weak sunlight, its atmosphere starts behaving like nothing we see on Earth. Inside Uranus's atmosphere. In the new images, Uranus is not just a soft blue ball floating quietly in the dark. Over its north pole, Webb caught a bright white cap spread across the top of the planet. It looks almost like a glowing hood. And this is not some small cloud drifting by for a few hours. It is a huge seasonal feature, spread across the pole of a planet where seasons do not come and go quickly. On Earth, a season lasts a few months. On Uranus, a season can last more than 20 years. Webb's newer view made that polar region clearer than before. It showed a bright white inner cap, and near the lower edge of that cap, a darker lane. That little dark band matters because it shows structure. It shows layers. It shows that the atmosphere is not just a smooth blue cover. Something is happening there. Uranus is now moving toward its next solstice in 2028. That is when one of its poles points most directly toward the sun. As that pole gets more sunlight, the cap becomes easier to see, and Webb is watching it change while it happens. Then come the storms. Near and below the southern edge of the polar cap, Webb caught bright storm features sitting in the atmosphere. They do not look like the huge, obvious storms we see on Jupiter. Uranus does not shout like that. It hides things under a calm face. But those bright spots are enough to change the whole story. For years, Uranus looked still because we were not seeing it properly. Voyager 2 flew past in 1986 and caught only a few clouds and dark spots. That old view made the planet look quiet. But later, observations started to break that idea apart. Ground telescopes, Hubble, Keck, Gemini, and now Webb all helped show that Uranus has clouds that shift, brighten, and change. Webb is simply the sharpest blow to the old story. Even the color is part of the trick. Uranus gets its blue-green face from methane in the atmosphere. Sunlight enters the air, hits the cloud tops, and comes back out toward space. But methane blocks much of the red part of that light, so what reaches our eyes is mostly blue and green. That is why Uranus looks so clean, so cold, so peaceful. But that beauty is misleading. The same gas that gives Uranus its calm color helps cover a place that is anything but calm. Under that soft blue face is an atmosphere moving at terrifying speed. Winds on Uranus can reach about 560 miles per hour, and even the wind cannot make up its mind. Around the equator, it blows against the planet's rotation. Closer to the poles, it turns and flows with the rotation. Then there is the cold. Uranus is not just cold because it is far away. It is cold in a way that feels wrong even for the outer solar system. Its atmosphere can fall to about -372 degrees Fahrenheit. That is colder than any natural place humans have ever measured on Earth. And the strangest part is that Neptune is farther from the sun. Neptune sits beyond Uranus, deeper in the solar system. Yet Uranus can still be colder in some places. That one fact makes Uranus feel broken all over again. Something about its heat, its air, and its past does not behave the way you would expect. Neptune has a strong inner warmth that helps drive its wild weather. Uranus has always been harder to explain. Newer work has made the picture clearer. Uranus is not completely heatless. It does release heat from inside, but compared with the other giant planets, that heat is weak, strange, and still not fully understood. And then the air gets worse. In 2018, researchers using the Gemini North Telescope in Hawaii found hydrogen sulfide in the upper cloud deck of Uranus. Hydrogen sulfide is the gas linked to the smell of rotten eggs. That detail sounds almost ridiculous at first, but it tells us something important. Uranus is not built like Jupiter and Saturn in the upper clouds. Those planets are known for ammonia ice high in their cloud layers. Uranus has a different kind of cloud chemistry, and that difference helps separate the ice giants from the gas giants. But if a human could somehow descend into the upper clouds of Uranus, the first problem would not be the smell. The cold would attack first. The air would not be breathable. The pressure would grow worse the deeper you went. The planet would kill you long before the rotten egg stink had time to become your biggest concern. But Webb did not stop at the atmosphere. Around that tilted planet, it also pulled a hidden ring and moon system out of the dark. Uranus's dark rings and frozen moons. Around Uranus, there is another system sitting in the dark. Most people do not think of Uranus as a ringed planet. Saturn owns that image. Saturn has the bright, wide, famous rings that look impossible to miss. But Uranus has rings too, 13 of them. But they are not bright and proud like Saturn's. The inner rings of Uranus are mostly narrow and dark gray. Farther out, the planet has two outer rings. One is reddish. The other is blue. Even their discovery happened in a strange way. In 1977, astronomers were watching Uranus pass in front of a background star. They expected the planet to block the star's light. That part made sense. But before Uranus covered the star, the starlight blinked out. Then, after the planet passed, the light blinked again. Something else was blocking it. That fits Uranus almost too well. Nothing about this planet seems to step forward willingly. Even its rings were discovered like a trap door opening for a second, then closing again. Webb changed the view completely. With its infrared vision, it captured the dim inner and outer rings with a clarity that older views could not match. One of the most important details was the Zeta ring. That is the extremely faint, spread-out ring closest to the planet. Any future spacecraft sent to Uranus would need to understand what is near the planet. A faint ring may look harmless from far away, but for a machine moving at high speed, tiny particles can become a real danger. And because Uranus is tilted almost onto its side, the rings look even stranger. Saturn's rings usually look like a flat band around the planet. Uranus does not give us that clean picture. Its rings can appear almost upright, wrapped around the planet like a tilted oval, and the rings may be telling us more than we thought. Newer observations suggest the outer rings are not all made the same way. The blue Mu ring appears to be fed by tiny icy particles from Mab, one of Uranus's small moons. The redder new ring may contain darker, dustier material, possibly rich in organic compounds coming from different source bodies. That means the rings are not just sitting there. They may be hints that tiny bodies are still shaping the space around Uranus in ways we are only beginning to see. Then Webb went after the moons. Uranus now has 29 known satellites, and one of the newest is so small that it slipped past the entire space age until Webb caught it. Its temporary name is S2025-U1. It was found in Webb images taken on February 2nd, 2025. The moon is only about 6 miles across. That is not a world anyone would notice easily from Earth. It is tiny, faint, and tucked close to the inner ring system. Voyager 2 flew past Uranus in 1986 and still missed it. Hubble missed it. Decades of telescope work missed it. Then Webb looked, and there it was. Even the moons of Uranus are named in one of the strangest ways in the solar system. Most moons around other planets are named after figures from Greek or Roman myth. Uranus went a different way. Its moons are named after characters from William Shakespeare and Alexander Pope: Titania, Oberon, Ariel, Umbriel, Miranda, Puck, Mab. And then there is Miranda. Miranda is less than 300 miles across, but its surface looks like something that has been broken and badly repaired. It has cliffs, grooves, craters, ridges, and strange patchwork terrain that still looks hard to explain. The most famous feature is Verona Rupes. It is often described as one of the tallest cliffs in the solar system. Its exact height is not perfectly settled, but estimates commonly place it around 12 miles high. That is more than twice the height of Mount Everest, standing on a small moon. But the strangest thing about Uranus may not be what Webb saw from the outside. It may be what happens the deeper you go. What's inside Uranus? Uranus is not a planet you land on. There is no ground waiting under the clouds, no hard surface, no place for a spacecraft to touch down, roll across, or plant a flag. If a machine entered Uranus, it would not crash the way it would crash into Mars or the Moon. It would sink. At first, it would pass through the pale blue haze that makes Uranus look so calm from far away. Then, it would drop into air, rich with hydrogen, helium, and methane. The light would fade. The gas around it would thicken. The pressure would keep climbing. There would be no moment when the clouds suddenly opened and revealed land below. The deeper the spacecraft went, the more the planet would close around it. Every mile would press harder. The air would stop feeling like air. It would become heavier, denser, more violent. The machine would be squeezed from every side until its body began to fail. And still, it would not have reached a surface. That is what makes Uranus so hard to think about. Our minds want a planet to have a top and a bottom. We want clouds above and ground below. But Uranus does not work that way. It is not built like Earth. It is an ice giant, but that name can fool you. Ice giant does not mean Uranus is a giant snowball. It does not mean there is a frozen shell you can stand on. The word ice is used because much of the planet is made from materials like water, methane, and ammonia. Out in space, those materials can freeze. But inside Uranus, they are not sitting there as clean blocks of ice. They are crushed into something far stranger. Most of Uranus is thought to be a hot, dense fluid made of water, methane, and ammonia, wrapped around a small rocky core. Deep down, near that core, temperatures may climb to around 9,000 degrees Fahrenheit. The only reason the material does not behave the way water behaves on Earth is pressure. Crushing pressure changes the rules. It can force matter into forms that do not fit neatly into the simple words we use every day. Not gas, not liquid like an ocean on Earth, not solid ground. Something in between. Something dense, hot, and trapped. And inside that crushing deep, scientists think something beautiful may be happening in the worst place possible. Diamond rain. Not jewelry falling through open air. Not giant sparkling stones dropping from clouds. The real idea is stranger and much more violent. Deep inside Uranus, methane is squeezed by extreme heat and pressure. Since methane contains carbon, that carbon may break away and form tiny diamond crystals under the right conditions. Those crystals would be heavier than the material around them, so they could sink deeper into the planet. That is the diamond rain of Uranus. This idea is not just a wild guess. In laboratory experiments, scientists have used powerful lasers to create brief, extreme conditions like those thought to exist inside Uranus and Neptune. In those experiments, tiny diamonds formed for an instant. Somewhere under that cold blue face, carbon may be separating, hardening, and sinking into the planet. The most beautiful thing in the whole system may be happening in a place that would destroy anything sent to witness it. And this hidden interior may help explain something even stranger: Uranus's magnetic field. The planet's magnetic field does not sit neatly in the middle the way you would expect. It is tilted, shoved off center, and warped in a way that makes Uranus feel broken all the way down. Uranus's broken magnetic field. Earth gives us the easiest starting point. Its magnetic field works a little like a giant bar magnet running through the planet. It is not perfect, and it is not simple, but for everyday life, it does the job. It helps guide compass needles. It helps shield the planet from charged particles from the sun. It gives Earth something like an invisible protective bubble. Uranus does not give us anything that neat. Its magnetic field is tilted almost 60 degrees away from the way the planet spins, and that is only the first problem. The field is also shoved away from the center of the planet by about 1/3 of Uranus's radius. It is like Uranus has an invisible shield that has been pushed to one side and twisted while the whole planet keeps rolling through space. You can see that weirdness in its auroras. On Earth, auroras usually appear near the poles. That is why people talk about northern lights and southern lights. The charged particles from the sun follow magnetic field lines down toward those polar regions, and the sky lights up. Uranus has auroras too, but they do not line up neatly with the planet's poles. They appear in strange places because the magnetic field itself is lopsided. Even the lights in Uranus's sky refuse to behave like they should. And behind the planet, the weirdness keeps going. As Uranus moves through space, its magnetic field stretches out behind it in a long tail, away from the sun. But because Uranus rotates sideways, that tail does not just stream out cleanly, it twists. The magnetic field lines wind around into a long corkscrew shape that stretches for millions of miles. A rolling planet dragging a twisted invisible tail through the dark. That is the kind of thing Voyager 2 flew into in 1986. Voyager gave scientists the only close-up magnetic data we have ever collected from Uranus. For decades, that flyby shaped the way scientists understood Uranus's magnetic bubble. But now, there is a new problem. A 2024 reanalysis suggests Voyager may have arrived at Uranus during a rare moment of space weather chaos. Researchers looked again at data from around the flyby and found that Voyager passed the planet just days after a strong blast of solar wind had hit the system. Solar wind is a stream of charged particles from the sun. When it slams into a planet's magnetic bubble, it can squeeze it, and in Uranus's case, it may have squeezed it hard. That solar wind event may have compressed the magnetosphere to about 20% of its usual size. That changes the whole feeling of the Voyager flyby. Some of what we thought we knew about Uranus may have been shaped by bad timing. That is why Uranus is so frustrating. Every answer seems to come with another trapdoor underneath it. Why we need to go back to Uranus. Uranus may be a close example of something much bigger. Around other stars, astronomers keep finding planets that are not quite like Earth, and not quite like Jupiter either. They are in between. Bigger than rocky worlds, smaller than gas giants, wrapped in thick atmospheres, and often hard to understand from so far away. That is where Uranus becomes important. For a long time, we treated it like the oddball of our solar system. But worlds like Uranus and Neptune may be common across the galaxy. Nearly 2,000 planets around other stars have been found in a similar size range. We cannot visit those planets. We cannot send probes into their skies. We cannot orbit them, watch their seasons, inspect their moons, or wait years to see how their weather changes. But Uranus is right here, in our own solar system. Far, yes. Difficult, yes. But still close enough that we can study it in detail if we actually decide to go back. That makes Uranus more than a weird blue planet. It makes it a test case. If we do not understand Uranus, then we may be misunderstanding a huge family of planets beyond our sun. And the planet is not the only reason to go back. Its moons may be hiding something of their own. New modeling has suggested that 4 of Uranus's large moons may contain internal oceans beneath their icy crusts. Those moons are Ariel, Umbriel, Titania, and Oberon, and something may be swimming under the surface. The reason that water could survive is chemistry. Ammonia and salts may be mixed into those buried oceans. On Earth, salt helps ice melt. In those moons, salts and ammonia could work like antifreeze, helping water stay liquid in places where it should have frozen solid long ago. And that is why Voyager 2 was never enough. Voyager gave us the only close-up visit to Uranus in human history. And if that one flyby happened during rare solar wind conditions, then the need to go back becomes even stronger. That is why the Uranus orbiter and probe matters. It has been named the top new flagship mission priority for the 2023 to 2032 planetary science decade. The idea is powerful. Send an orbiter to live in the Uranus system and send a probe down into the planet itself. The orbiter would study the atmosphere, rings, moons, interior, and magnetic field over time. It would stay long enough to watch the system breathe, shift, and reveal patterns that a flyby could never catch. But the probe would be the part that feels almost brutal. It would not go there to survive. It would go there to fall. It would drop into the atmosphere, measure what it can, send the data back, and keep descending until the cold, pressure, and darkness finally destroyed it. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.